All right, you're finished with your first unit test, and let's go ahead and get started on Unit 2, which begins with Chapter 4. Now in Chapter 4, we're going to talk about atoms, and this unit includes Chapter 4 and 5, so we're going to be talking about atoms and the periodic table. Go ahead and have your periodic table out and ready to look at. You're going to need to reference it today. And let's go ahead and get started with the beginnings of the atomic theory. So this just means the ideas of how we figured out what the atom was made of and how the atom is composed. Now, the first scientist that contributed to the atomic theory was Democritus, and he suggested that the universe was made of tiny units called atoms. So he was the first one to actually discover and believe that everything was made up of atoms. John Dalton, he contributed and told us that all atoms of the same element are alike. So if I have an oxygen element, then all of the atoms that make up that oxygen element are oxygen atoms. He also contributed that atoms of different elements were not alike, but they could join to form compounds. J.J. Thomson is our third scientist. He discovered electrons. So J.J. Thomson was the one that discovered electrons were a part of atoms. And then he believed that the electrons were in the form of a plum pudding model. So he believed that the atom looked like plum pudding. Now, most of us don't know what plum pudding is. Maybe you can talk to your parents tonight and ask them to make some. But what I equate plum pudding model to is like a blueberry muffin. If you've got a blueberry muffin, the blueberries in the muffin are not organized in a certain way. They're just placed randomly. So J.J. Thomson believed that the electrons were just random throughout the entire atom, and they were almost like they looked like a blueberry muffin. If you think of the muffin part being the atom, the blueberries being the electrons could just be anywhere. That's what he believed at first. Then Rutherford came along, and he actually discovered the nucleus of the atom, and he figured out that most of the mass of the atom is in the nucleus, so it's in the center of the atom. He also discovered that electrons are not randomly placed like J.J. Thomson thought. He figured out that electrons do orbit the nucleus, so they travel around the outside of the nucleus. These are the four scientists that we've discussed today that contributed to the atomic theory. Now let's look at the modern theory. The modern theory no longer assumes electrons orbit randomly like J.J. Thomson did. We now believe, like Rutherford discovered, that they orbit the nucleus and that they orbit the nucleus in a certain direction, and that there also is a pattern to it. Now, electrons can only be found in certain energy levels, and we're going to talk about energy levels a little bit later in Chapter 4. And we also believe now that it's impossible to know the exact location of an electron. So these are three ideas that we believe now in the modern atomic theory. And those four scientists helped us to come to these conclusions. Now let's go ahead and look at what an atom is. Atoms are made up of various subatomic particles. So you have the atom, which is a tiny tiny thing in itself. Then you've got even more tiny things that make up those atoms. The three main subatomic particles are distinguished by mass, charge, and location. And all that means is they have different masses, different charges, different locations. Now, a proton is our first subatomic particle we're going to talk about. It has a positive charge and is found in the nucleus. The neutron is the second subatomic particle. It has no charge, but it's also found in the nucleus. And then electron is our last subatomic particle. It has a negative charge and is found outside the nucleus. It's not found in the nucleus. Now, at the center of each atom is a nucleus. We discussed that just a few minutes ago. And the nucleus is made up of protons and neutrons, not electrons. Make sure you know that electrons are not in the nucleus. And this is where most of the atom's mass is found. This is where most of everything that makes up an atom is in the nucleus. The nucleus always has a positive charge, and the reason being it's made up of protons and neutrons. Protons have positive charge, neutrons have no charge. So that means the nucleus will always have a positive charge. Now let's talk about electrons for a minute. Electrons orbit around the outside of the nucleus in certain energy levels. The mass of an electron is much smaller than that of a proton or neutron. And that's why most of the mass is in the nucleus, because protons and neutrons are much larger than electrons, so their mass is much more. Now, when you have an element, when you're looking at your periodic table right now, look at each individual box. Each individual box represents one element, one type of element. And each one of those have a unique number of protons. And what you need to know is that if the protons change, the element changes. You cannot have a helium element or molecule with one proton because hydrogen is one. And so each one of them have their own number of protons, and it's a unique number. It's kind of like our DNA. You know, each person has their own DNA. If my DNA changed, I would be a different person. I wouldn't be Angela Swilly. It's kind of like fingerprints. Remember that all of us have unique fingerprints? And so if our fingerprints changed, it would be someone else. It wouldn't be us. And so protons are kind of like DNA to people. So anytime you have a number of protons, that number of protons tells you exactly what that element is, or which element we have. When you have an atom or an element that has not reacted with something else, then they have a zero charge. They don't have any charge at all because they've not reacted with anything else. And I'm going to show you why that is. Let's look at helium. Go ahead and on your periodic table find helium. Now, helium, and you're going to learn how to tell this in just a second on your own, but helium has 2 protons. So if we have 2 protons, that means they have a +2 charge. Helium also has 2 neutrons. Remember, neutrons have no charge, so that's a 0. Helium also has 2 electrons, and that means that we have a -2 charge. So do you see that when you add those up, that all equals 0? And so the total charge of the helium atom is 0. So anytime we have an atom that's unreacted, that's just like you're looking at it on your periodic table, it has a 0 charge. Now, what holds these atoms together? I mean, how do they not just fall apart? And the reason being is because they have an electric force. And that electric force is created by the positive and negative charges inside of the atom. The positive and negative charges attract each other, and so that's known as the electric force. So the positive is in the middle, the negative is orbiting around the outside, and that's what holds everything together in an atom. Since electrons have a negative charge and protons have a positive, they are attracted to each other. Remember, opposites attract. That's what people say when they're talking about relationships, but that's definitely true in science. So always remember, opposites attract. Positive attracts negative. Now, I told you were going to know how to determine how many protons, neutrons, and electrons an element has, and we're going to do that right now. The atomic number. The atomic number is one of those numbers you see in the boxes in the periodic table, and it equals the number of protons. It equals the number of protons. Now, the atomic number is the number on top of the element symbol, and I'm going to give you a picture in just a moment so we can look at it together. Each element has its own number of protons. We've already talked about this. And the atomic number also equals the number of electrons. So that number on top of the element symbol is the protons and the electrons. Now, the mass number is the number of protons plus the number of neutrons, and that makes up the mass number. The number of protons are going to equal the mass number minus the number of neutrons. Now, your mass number is below the element symbol, okay? It's the one underneath the element symbol, and that's the mass number. So you take the number of protons plus the number of neutrons, and it gives you that mass number. Now let's look at this. This is what you should be seeing on your periodic table, and I just took one box out of it to look at. So you have Ge, which is the element symbol, germanium, which is the name, 32, which is the number on top of the element symbol, that's the atomic number, and that tells us the number of protons and the number of number of protons and the number of electrons. So the atomic number gives us protons and electrons. So germanium has 32 protons and it has 32 electrons. Now let's look at the mass number. The mass number is below the element symbol, and it's 74. Now this is the number of protons and neutrons added together. So how do we find out what neutrons are? And you're going to learn this in your notes in just a second. So if you look down below the pictures, the number of neutrons equals the mass number minus protons. So we know that protons are 32, electrons are 32, and now to find out the number of neutrons, we say 74 minus 32. You always take the mass number minus the number of protons, or you can also say bottom number minus top number. That helps you also. And that will tell us that there are 42 neutrons in germanium. So this is an example that you can come back to if you need further help or if you forget how to do it. Germanium has 32 protons, 32 electrons, 42 neutrons. Now, let's look at this. The mass number and atomic number can be written in a different way other than what you see on the periodic table. And we call this way max. And if you'll notice, it's because we have mass number here, and we have atomic number here, so we say M, A, and then you got X for the atomic symbol or the element symbol. So we call that max a lot of times. It's written in the form of max. And so this is an example to your right showing you how that would look. We've got sodium with its mass number of 23 at the top left, and its atomic number of 11 at the bottom left. Now let's go ahead and practice figuring out protons, electrons, neutrons with sodium as well. So we have 11 protons for sodium because that's the atomic number. We have 11 electrons for sodium because that's the atomic number. And remember, to find neutrons, we take the mass number minus the atomic number, or you can say mass number minus the number of protons. So you take the mass number 23 minus 11, and that gives you 12 neutrons. So it means we have 11 protons, 11 electrons, and 12 neutrons. Now this is what I probably should have had before these pictures. I apologize. But this is how you calculate the number of neutrons. This is where you take the mass number minus the number of protons. And again, remember, the number of protons is also the atomic number, so you can say the mass number minus the atomic number, or the bottom number minus the top number if that helps you. Now let's do some practice. What I'd like you to do is I want you to figure out how many protons each of these elements have. So I want you to pause the tape and then come back and check your answers. But just write down protons right now. All right, check your number of protons, and if you didn't get it right, look to see why you didn't get it right. Now, let's go ahead and practice finding electrons. So what I want you to do is pause the tape, write the number of electrons for each of these, and then restart the video once you're ready. All right, hopefully you're getting most, if not all, of these correct. The last thing that we want to practice is finding and calculating neutrons. So let's go ahead, pause the video, write the number of neutrons and calculate the number of neutrons that each one of these elements have, and then resume the video once you're ready to check your answers. If you got all of these correct and have no questions, I would like you to go ahead and do your summary, which is going to be a tweet today. When you're on your Twitter account, you can make a tweet of 140 characters. So I want your summary to be only 140 characters, what you would tweet about what we learned today. If you have a few questions and you didn't get some of these right, then stick with me. I'm going to go over a couple of those to explain how we got the answers that we did. Now for lithium, if you'll look at your periodic table and find lithium, lithium has an atomic number, which is the top number, of 3. So that means protons and electrons are both 3. Then look at its mass number. Its mass number underneath lithium is 6.9. We're just going to round that because you can't have 6.9 neutrons or 6.9 protons or whatever. You can't have a decimal place. So we'll round that to be 7 minus 3, which gives us 4. Same thing with boron. Locate boron on your periodic table. The very top number is the atomic number, and that gives us protons and electrons. So we have 5 protons, 5 electrons. The bottom number gives us the protons plus the neutrons. So we always say, we're going to say 11 minus 5, so the bottom number minus the top number is going to give us 6 neutrons. If you have any other questions, write them on the left-hand side of your paper, and we'll discuss this and practice this more when you get to class. Have a great evening.